Welcome back. Today we're doing problem 2428, maximum sum of an hourglass. You're given an m by n integer matrix grid. We define an hourglass as part of the matrix with the following form, right? So A, B, C, D, E, F, G, 3 on top, 1 in the middle, and then 3 on the bottom. Return the maximum sum of the elements of an hourglass. So they want you to add up all of the values comprised of hourglasses with this shape, find the one that has the largest sum, and return that. Note that an hourglass cannot be rotated and must be entirely contained within the matrix. So let's take a look at this example here. In this example, the output is 30, and actually let me just go to this beautiful diagram I made. It's the same matrix. The output's 30 because the winning hourglass, the hourglass with the largest sum, is this hourglass. They kind of look like eyes. So 3 on top, 1 in the middle, 3 on the bottom. You add these all together, 6 plus 2 plus 1 plus 2 plus 9 plus 2 plus 8. That gives you 30, right? So when you see a problem like this, it's easy to, at least for me, to be kind of like, oh man, it's a graph. I gotta figure out hourglass shape. What does this mean? It's really easy to kind of panic and be like, oh, I don't know what to do. But it's actually quite straightforward. Something to keep in mind is here, note that an hourglass cannot be rotated and must be entirely contained with the matrix. So you don't have to worry about something like, let's see, something like this. Like if we flipped this matrix, right, you don't have to worry about an hourglass of shape, I don't know, something like this, right? Like if I flipped it on its side, this is an invalid hourglass. This is not a valid hourglass. They have the same shape. I just flipped it by 90 degrees. That's not a valid hourglass. So when you're thinking about this problem, what we want to do is just try to keep it simple, right? How do I know the maximum hourglass? Well, I have to calculate, what's one approach? Let's just calculate all of the hourglasses, right? Let's just maintain a maximum sum. Let's call this sum. In this case, it's 30, right? That's our first hourglass. What do we do after that? Well, let's just move on. Let's move on to the next hourglass. What's the next possible hourglass that we could have? Well, it's this one, right? Oh, come on. If we start here, then our next possible hourglass is this hourglass right here. That is a terrible, yeah. But the point is, you just keep going and you figure out what the sum is. And the sum in this case is 2 plus 1, 3 plus 3 is 6, plus 1 is 7, plus 2 is 9, plus 8 is 17, plus 7 is 24. That's not larger than this sum, so you keep this sum. You just take the max. What we're going to do is we're just going to traverse this entire grid, and we're going to calculate the hourglass sum. Something to keep in mind is, well, not every one of these positions is going to yield a valid hourglass, right? If I am at this bottom cell here, well, I can't create an hourglass because there's nothing below me. And if I'm at this hourglass here, if I'm at this starting position here, I can go down, there are values below me, but there's nothing to my right. So we're gonna have to just check to see if, hey, starting from the topmost left corner as the start of our hourglass, do we have enough valid space to go right? And also that means that if we have enough valid space to go right, we have to check if we have enough valid space to go down. Basically just checking if we are staying within the bounds of our matrix. This looks like a complete mess. Let's just code this up and then I'll explain this as I go. So what we're gonna do here is let's maintain a maximum sum, and I'm just gonna set that to negative math.infinity first, and we're gonna say we have a right bound, but actually we'll do that later. We'll define that within our loop, right? So we're gonna loop. I'm just gonna do this. Rows is equal to the length of the list. Columns is equal to the length of the list and index 0, because it's an m by n matrix, right? They don't share the same dimensions. It can be different. The number of rows can be different than the number of columns. So now what we're going to do is we're going to loop through the number of rows, right? Just a regular double for loop. And we're going to define our bound, right? Remember earlier we said that you have to be a valid hourglass starting at the top left position. You cannot go out of bounds to the right or below. So this is how we're going to check, right? So at position ij, the furthest you can reach is your right bound here, and the furthest down you can reach is your bottom bound here. So we are a valid hourglass, and we should only calculate the sum if right bound is strictly less than the number of columns and bottom bound is strictly less than the number of rows, right? So now what do we do? Let's go back to this diagram, right? Once we know that we're at a valid position, like this 6, we have to calculate the top row, the middle value, and the bottom row. I'm just going to store all of those. You can probably do this in a loop somehow, but honestly, doing this problem, I think it's pretty straightforward, for me at least, to just define them as top left is equal to my grid at the position that I'm already at right now. Top middle is equal to same position, but over one column. And then my top right is equal to same position, but over 2 columns. And now I'm gonna call this, I'm actually just gonna call this middle, is equal to grid at I plus 1 and also j plus 1, right? We're moving over to the right one and also moving down 1 to calculate this middle section here. If this is our top row, our middle section is down a row over a column. Now we're gonna do the bottom. Bottom left is equal to our grid at I plus 2. And you know what I'm seeing now is we could probably just use these right and bottom bound values. That would have been smarter and made more sense, but I'm just gonna do it this way because we're already doing it. I plus 2 and then j. And then our bottom middle is equal to j plus 1. Our bottom right is equal to j plus 2. Move this over here. And now we're going to do our current sum is equal to top left plus top middle. We're just going to add these all up. Say that max sum is equal to the max of max sum and current sum, right? We're just always going to take the larger of the two values. We're always going to take the largest hourglass that we can calculate. Top left, top middle, top right, middle, bottom left, bottom middle, bottom right. All right. When this finishes, we should just be able to return our max sum. And that should be it. Let's see if this works. rows equals length of our, this is not list, this is actually grid, sorry. Great. Cool. So for this problem, let's talk about the runtime and space complexity. So runtime wise, it's O of n, and I know that there's two loops, so you're thinking, okay, it's n squared. But remember that this is a matrix, right? And when we're talking about runtime, n is representative of the total number of elements that we have. So it's actually O of n. We're going through the matrix once. These are all, I think, these are all constant time operations. Like, we know exactly how many grids, cells, we're going to take into consideration and do math on. And so that's why this is still O of n. Space-wise, it's O of 1. We're not maintaining any auxiliary space. We're just maintaining this variable here that we're going to return at the end. So there might be a better way to do this where it's a little bit cleaner. And to me, honestly, I don't think this is too complex. But yeah, there might be a better solution, but this is just how I did it.